everyone, welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Today we discuss about CBNST, which has been the computer-based numerical and statistical technique, and that has been the classes your 43rd class, and where we have to cover up the 42th classes of the session. In the last session we had done, and we even though had started with 43rd class of the session in today's class. Before that we had done your unit 1, which has been the computer based numerical and statistical technique, that has been the computer arithmetic, errors and rules of equation. In unit 2 we had done your interpolations and converting, and for unit 3 which we have started with, and there we had started in the last classes, so where we had started numerical differentiation and integration, and that has been the important unit as well. Then after that we will to go ahead for the last unit of this subject as well. So here, before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So today we'll go started with the velocity of a car running on a straight road at an interval of 2 minutes that are given below, and then we have your table as well, the time, minute and velocity with kilometer per hour. You have to find the difference that is being covered by the car. You have to justify for the method used as well. So we go for the same. The velocity of the car running on a straight road at interval of 2 minutes are given below. We have your table. Time, minute and velocity, kilometer per hour. This has been 0. This has also been 0. 2, 22, 4, 30, 6, 27, 8, 18, 10, 7, 12, 0. Find the distance. Find the distance covered by the car. Justify for the method used. So we go for the same here, that what we'll have to talk about it. And so here there are 7 data points, that is odd, and hence we will use Simpson 1/3 rule. The given time is in minutes. Let us convert it to hours and rewrite the data to be as follows here as well. So we go for it. This is time for hour, and OB for kilometer per hour. So T0 equals to 0.60 and V0 equals to 0. T1 equals to 2.60 and V1 equals to 22. T2 equals to 4.60 and V2 equals to 30. t3 equals to 6 upon 60 and v3 equals to 27, t4 equals to 8 upon 60, v4 equals to 18, t5 equals to 10 upon 60 and v5 equals to 7, t6 is equals to 12 upon 60 and v6 is equals to 0. So let r be the distance covered by the car, and then we write it down here in the form equals to dr upon dt. That is, the velocity is given as a derivative of distance with respect to the time, and we can write the above equation for the dr equals to v dt, and you have to integrate both sides. It will be integration of dr equals to integration of v dt, and here that dr, the integration of dr is the distance covered by the car. You have to consider the Simpson 1/3 rule, which is x0 to xn y dx equals to h by 3 y0 plus yn plus 4 y1 plus y2 plus y3 sorry y1 plus y3 plus y5 plus 2, that is y2 plus y4 plus y6. Till putting these value in the equation, we will get distance equals to h by 3 v0 plus v6 plus 4 v1 plus v3 plus v5 plus 2 v2 plus v4. So here h is equals to t2 minus t1 equals to 4 upon 60 minus 2 upon 60, which is equals to 2 upon 60. So hence above equation becomes here answer for the same. It will be distance is equals to 2 upon 60 upon 3, 0 plus 0 plus 4 22 plus 27 plus 7 plus 2 30 plus 18. So which will be giving you equals to 3.5555 and 56 kilometer. And on the same, thus the car will cover 3.555556 kilometers of distance. For the justification for the method that is being used here, that the given data that has of 7 odd data points and 6 even segments, so hence Simpson 1/3 rule is suitable for such data. We go for the next, and that we talk about it has been another question. Use Simpson 1/3 rule and trapezoidal rules to evaluate, that has been 0 to 12 log e1 plus x square dx by taking suitable number of intervals. Comment on the results we'll have to. So for using Simpson 1/3, we go for the same. For Simpson using 1/3 rule. For Simpson 1/3 rule, we know that even that the numbers of the segments and that are used, and hence let us the n equals to 6 here, and that is the sequence which has been here for that x0 is equals to 0 and xn equals to 12. So we'll put the value h is equals to xn minus x0 upon h n, and it will be 12 minus 0.6. 6 ones are 6, 6 twos are 12, it will be your 2. Let us form the table of the data points that as follows. We made a table for it. It will be y equals to log e 1 plus x square, x0 equals to 0, y0 equals to 0, x1 equals to 2, y1 equals to 1.6094, x2 equals to 4, y2 equals to 2.8332, x3 is equals to 6, and y3 equals to 3.6109, x4 equals to 8, y4 equals to 4.1743, x5 equals to 10, then y5 equals to 4.6151, and y6 is equals to 12, and that has been your 4.8767 that we have here. So Simpson 1 by third rule which will apply here, it will be giving you the similar x0 xn by dx equals to h by 3 y0 plus yn plus 4 y1 plus y3 plus y5 plus 2 y2 plus y4 plus y6 for n equals to 6, that has been x0 to x6 y dx h upon 3 y0 plus y6 plus 4 y1 plus y3 plus y5 plus 2 y2 plus y6. Putting the values in the above equation, we get log e 1 plus x square dx equals to 2 by 3 0 plus 4.9767 plus 4 1.6094 plus 3.6109 plus 4.6151 plus 2.8332 plus 4.1743. It will give you the answer here, 338.888867 that we have here. That what we'll have to discuss as well. So for the same, the next we talk about it. After that we will do the second one, which has been the using the trapezoidal rule for it, and we made it for that same. We go for the same here. So we go for the second method. It will be using trapezoidal rule, and for the same it will be, let us use the same number of the segment as in the previous case where the trapezoidal rule is to be given here. That has been x0 to xn y dx equals to h by 2 y0 plus yn plus 2 y1 plus y2 plus y3 plus y4 plus till yn minus 1. So for n equals to 6, we'll be having x0 to x6 by dx equals to h by 2 y0 plus y6 plus 2, y1 plus y2, y3 plus y4 plus y5. Putting the values in the equations here. 0 to 12 log e 1 plus x square dx equals to 2.2, 0 plus 4.9767 plus 2, 1.6094 plus 2, that is 2.8332, then plus 3.6109 plus 4.1743 plus 4.6151, and it will give you the answer, and that has been 38.6625. Okay, now for this we obtain the result as, and that has been in the form which has been as follows method. This has been answered. So for that it has been your trapezoidal rule and Simpson 1/3 rule. So for answer for trapezoidal it has been 38.6625, Simpson 1/3 rule 38.888867. That we have. The actual value of integration is 38.6961, and here you have to know the trapezoidal method that has less errors that compared to the Simpson 1/3, so that we get as an answer as well. Now we talk about it, we'll use the Simpson 3/8 rule here. The Simpson 3/8 rule, we talk about it. The question we have, evaluate 0 to pi by 2 e sine x dx using Simpson 3/8 rule with 6 sub intervals. So we find it out for the same. So here sub intervals we have n equals to 6, x0 equals to 0, xn equals to 5/2, and for the same it will be h equals to xn minus x0 upon h, 5/2 is minus 0 upon 6, and that is being equals to pi/12. So y equals to e sine x is being calculated in different values of the below here. This has been x and y, x0 equals to 0, y0 equals to 1.0, x1 equals to pi/12, y1 equals to 1.295399. That is when we have to discuss about. x2 equals to 2 pi upon 12, y2 equals to 1.648721, x3 is equals to 3 pi upon 12, y3 equals to 2.028115, x4 equals to 4 pi upon 12, y4 equals to 3.7743, and x5 is equals to 5 pi upon 12, y5 equals to 2.6271. Then we have your for x6 4 pi upon 12 equals to pi by 2, and y6 is equals to 2.718282. Then we go for that is for n equals to, that is Simpson 3 by 8 rule is being given. X0 x6 yd equals to 3h upon 8 y0 by y6 3y1 plus y2 plus y4 plus y5 plus 2y3. Putting the values here, which is being 0x pi by 2 e sine x dx equals to 3 pi by 12 upon 8, 1 plus 2.718282 plus 3 1.295399 plus 1.64872 3.77443 plus 2.627219 2 into 2.02 8115 equals to 3.515817 here, that we talk about it. And on the same page we have to discuss many more here, and that is being as follows, which we have to talk about it. That is also being important. We'll go for the next question here too, and that is being as follows here. So that what we'll have to discuss here. Other question is to evaluate the integral 0 pi 4 plus 2 sine x dx using Simpson's 3 by 8 rule, where n equals to 5. Compute percent relative error. So for the same we go for the same here, and that is being n equals to 5, h is equals to x and minus x0 upon n, which is being pi minus 0.5. So h is equals to pi by 6, pi by 5, or h equals to 36 degree. Let's calculate the table here, that we talk about it. So first we talk about x, and this is being by x0 is equals to 0, y0 equals to 4, x1 equals to pi by 5, and y1 equals to 5.176, x2 equals to 2 pi by 5, and y2 equals to 5.902, x3 equals to 3 pi by 5, and y3 equals to 5.902, x4 equals to 4 pi by 5, and y5 equals to 5.176, and then x5 equals to pi, and y5 equals to 4. So for that we go for the same, in the same way we go for n equals to 5, and we can write the Simpson 3 by 8 rule here, that we have to talk about it. That is for the same we go on, which will be the important one, is as follows: x0 to x5 y dx equals to 3h upon 8, that is y0 plus y5 plus 3 y1 plus y2 plus y4 plus 2y3 Putting the values 0 to pi, that is being 4 plus 2 sine x dx equals to 3 into pi by 5 upon 8. 4 plus 4 plus 3, 5.176 plus 5.902 plus 5.176 plus 2 into 5.902. It will give you the value here 16.155483, and the actual value for the same we get here is I equals to 0 से pi, that is 4 plus 2 sine x dx equals to 4 x plus 2 minus cos x 0 से pi, that is equal to 16.566371. Percentage relative error equals to 116.56671 minus 16.155483 whole upon 16.5 66371 into 100 equals to 2.4805% that we have here. And so now we go for the that has been, and that we're gonna end up with this, and we will be discussing the rest of the course, the classes, the rest of the unit in the next coming class, and that is of course being the important one here. So we continue with the 44th class, the rest of the classes here, but before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel, so that many and maximum people can get the information at once, and whether you can also enjoy the video as well. Other than computer based numerical and statistical technique, we had done your sociology and software engineering as here. That is we have to discuss here, and that has been the chemistry which we have to discuss here. The chemistry for class 11th we had done for part 1, and chemistry for class 12th which we had even the started we had done for part 1, that has been the unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, with the conversions, logarithms and antilogs as well. After talking about that, yes, in terms of it, we have started with part 2 for chemistry, and that is of NCRT, and yes, of course, for physics part 1 we had even though started with quantitative aptitude. In that we had started the arithmetical ability. In that we had done your that has been the operations on numbers, SCF and SCF of numbers, fraction, simplification, square root, and cube root, problems on numbers, problems on ages, and this is percentage, profit and loss, inflation, proportion, which we have to start with. After talking about that, we had done your reasoning. In that we had done your general mental ability and logic reasoning, and in non-verbal reasoning we had done series and logic classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation analysis, and practice question set as well. In terms of it, after talking about that, we had to start with ER diagrams. We had done we are dealing with PHP interview question, we are dealing with English vocabulary, we are dealing with many more that we have to discuss about it. And in terms of computer based numerical and statistical technique, we had done unit 1, which has been that we have to discuss here. So for the same, we talk about it in computer arithmetic errors, that is in the floating point arithmetic, machine second round of error, chopping error, truncation error, associative and distributive law in the floating point error, arithmetic, inherent error, error propagation, numerical instability, rules and equations, second method, Newton-Raphson method, and a fixed point iteration method for simple rules and derivations of the rate of the conversion, static and acceleration of the conversion, modified Newton-Raphson method, that for the multiple rules, Birch-Beighton method for polynomial, Weierstrass method for quadratic factor, and computer algorithm of these method as well. In unit 2, we have to cover up the interpolations and curve fitting, where we had started with the algorithm and the error analysis of Lagrangian, the Newton's divided differences, interpolations, relationship in the various differences operator, piecewise linear interpolation, cubic spline interpolation, Nachtschluss line, Chebyshev's polynomial approximation, Lenkos economization of the power series. In curve fitting, we have to cover the linear and non-linear least square approximation, conditioning with the least square method, Gram-Schmidt process of orthogonalization, computer algorithm of least square curve fitting. learning. In terms of unit third, which is differentiation and integration, we have started with meta based on the interpolations and finite differences, Richardson extrapolation, and analysis of trapezoidal and Simpson method, Newton-Cotes integration method, Gaussian integration method, Gauss-Lagrange method, Lobato integration method, Redound integration method, error terms in pertaining integration method. In unit 4, we have to cover up the solution of the simultaneous linear algebraic equation. We have to cover up the Gauss elimination method, condition system, condition number successive over the relaxation method, rate of the conversion, solutions of ordinary differential equation. We have to cover up the single step method, Runge-Kutta second order, third order, fourth order method, multi-step method, predictor and corrector method, in statistical HAP technique. We have to cover the statistical hypothesis, type of hypothesis, type 1 and type 2, errors, level of significance, test involving the normal distribution as well. So here we're gonna end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.